Video 19, levels of measurement, and also a little bit of revision on graphs. Levels of measurement are nominal, ordinal, and interval data, and they mean slightly different things. Nominal data is categorical data. It's data that can be put into categories. So, for example, nominal data would be, what's your favourite school dinner? Is it fish and chips? Is it curry? Is it shepherd's pie? Whatever it might be. And I could draw a bar chart with nominal data, couldn't I? I could get 100 school children and ask them what's their favourite school dinner and draw a bar chart for that nominal data. Ordinal data adds a little bit more information. It's a richer source of data. So ordinal data puts things in rank order. So each child would have to decide not only what's their favourite school dinner, but what's their second favourite, what's their third favourite, what's their fourth favourite, all the way down to their least favourite. And they would have to put them in order. So it gives a little bit more information about their choices. It's a richer form of data. Interval data is an even richer form of data. And this gives actual numbers. And it has to be an objective measurement. Something that's actually measured. So, for example, it could be the weight of the school dinners, or the calorific content, or the time it takes the children to eat them. Something that can be actually objectively measured. A rating scale is always ordinal. In order to be an interval data, it has to be actually objectively measured. Ratio data is very closely related to interval data. They're not going to ask us about ratio data on the exam. The difference is that ratio data has a true zero, whereas interval data doesn't, but I'll leave that to the mathematicians to explain. Okay, let's imagine that we've got a race and we've got 10 people running this race, and I'm going to give them letters A, B, C, D, E, F, G, H, I, J. And we can write in some invented finishing times that it takes to run this race. Person A finished the race in 3 minutes and 2 seconds. Person B finished it in 3 minutes and 1 second. Person C finished it in 3 minutes and 32 seconds. And so on. 10 different finishing times. Now, once we've got the finishing times, we can work out who won the race, who came second and who came third. We can write in their positions, and we can see that F won the race. F for fastest, run the race by quite a long way, but there was a pretty tight race for second place. So person B and person H tied for second place on 3:01, and then just behind them was A on 3:02. And everyone else has a ranked position in the race. Once we know those two forms of data, we can also give them a time category as well. So I can create time categories which go from 2 minutes 30 seconds to 2 minutes 59 seconds. That's the first time category. The second time category would be 3 minutes to 3 minutes 29 seconds. The third time category, 3 minutes 30 seconds to 3 minutes 59 seconds, and so on, all the way up to 6 minutes and 59 seconds. And then I can put the people into the time categories. So person A finished the race in 3 minutes and 2 seconds. That puts them into time category 2. Person B also finished the race in the same time category 2. Person C took 3 minutes and 32 seconds and they finished in time category 3. And everyone can get put into a time category. Okay, so once I've got this data, I can draw a histogram. And on this histogram, I'm going to have the number of competitors, the frequency of competitors on the y-axis, and on the x-axis I'm going to have the time categories, the finishing times in minutes and seconds that I worked out a moment ago. And if I draw in my bars, I can see that the winner of the race, person F, was the only person who finished in the fastest time category. There were 3 people who finished in the next time category, 3 minutes to 3:29. Another 3 people who finished in the third time category, 3 minutes 30 to 3 minutes 39, and 3 minutes 59, I beg your pardon, and so on. And so this is a histogram where the bars are touching and it shows the distribution of the finishing times of people in this race. And I know it's a histogram because the bars are touching one another. And if I want to, I could draw a line joining the center of the top of each bar. And that would be a frequency polygon. A frequency polygon gives me exactly the same information as a histogram. We can also categorize our measures of central tendency and our measures of dispersion into nominal, ordinal, and interval. The mode is just nominal data, that's just one category. The median and the range are ordinal data, and the mean and the standard deviation are true interval data because those give actual numbers. Graphs. They can give us graphs to draw, and we've got to know when you draw a histogram and when you draw a bar chart. How can you tell? Right. You draw a bar chart when you have got nominal or ordinal data in non-overlapping categories. So the example of this would be, which school dinner do you prefer? You could have a bar for shepherd's pie, a bar for chicken and chips, a bar for all of the different options that you would have in school dinners. This is when you leave gaps between the bars because the categories don't overlap, and that is a bar chart. A histogram, on the other hand, is like the one that I drew a moment ago for my running race. And a histogram is suitable for interval or ratio data. But can you note that when I drew my histogram, I collapsed the interval data into categories, which was 2 minutes 30 to 2 minutes 59, 3 minutes to 3 minutes 29, 3 minutes 30 to 3 minutes 59, and so on. So what I did is I took my interval data and I put it into categories, and that is how you draw a histogram. Histogram is suitable for interval data that has been put into categories. That means that the data is continuous data. That means, for example, that the 2 minutes 30 to 2 minutes 59 category touches the 3 minutes to 3 minutes 29 categories. There's no gap between them. You couldn't fall between those two times. You're either in one category or the other. And so that means that the bars have to touch on a histogram. Also, if there's empty values, like no one fell into some of those categories that I drew on my bar chart, and that means that you draw a bar of 0 height. It's not that there's a gap between the bars, there are bars in there which have 0 height. And if my categories are of equal intervals, then the bars should be equal widths as well. If you haven't got equal intervals, then you do have to do bars of different widths, but that only really comes up on the higher tier of GCSE maths, and we're not going to worry about it in this video. So, bar charts use nominal are used for nominal or ordinal data, and histograms are used for interval or ratio data that has been put into categories.